Welcome to AMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. I'm Madam Wong here. Formative Exercise 8.3. Number 1. A particle passes a fixed point O with an initial velocity of 30 meters per second and moves along a straight line with an acceleration A equals to 12 minus 60 meters per second square, where t is the time in seconds after passing through the point O. A. Calculate the velocity in meter per second when t equals to 2. So let's see the information given. A equals to 12 minus 60 and we need to calculate the velocity. So from acceleration we need to get velocity. We need to do integration. So v equals to the integral of acceleration with respect to t. We get v equals to 12t minus 3t squared plus c. And where is the c from? When t equals to 0, our initial velocity is 30 meters per second. So when t equals to 0, v equals to 30. Therefore, the c is 30. Okay. Then, we need to calculate the velocity when t equals to 2. Now we can sub in t equals to 2 into the function of velocity. So v equals to 12 times 2 minus 3 times of 2 squared plus 30. There we get v equals to 40 meters per second. B. Where is the particle when t equals to 1? When we ask where, we need to tell the position of the particle. First, we get the displacement of the particle. So we do integration from the function of velocity with respect to time. We get 6t squared minus t cubed plus 30t. And then you will see the c will be equals to 0 because when t equals to 0, the displacement is on the fixed point O. So means that when t equals to 0, our s equals to 0, therefore the c will be also 0 for s. So when t equals to 1, our displacement will be 6 times of 1 square minus 1 cube plus 30 times 1. So we get s equals to 35 meters. This is positive 35 meters. So we can conclude that the particle is 35 meters on the right of the fixed point O. Question number 2. A particle moves along a straight line and passes through a fixed point O. At t seconds after passing O, its velocity v meter per second is given by v equals to 24t minus 6t squared. Calculate A. The initial acceleration in meter per second square of the particle. So we are given the function of velocity 24t minus 6t squared. We need to get the acceleration. So we do differentiation. There we get a equals to 24 minus 12t. So initial acceleration happens when t equals to 0. So when t equals to 0, we sub in, we will get a is only equals to 24 meters per second square. B. The value of t in seconds when the acceleration is 0. So when the acceleration is 0, a equals to 0, 24 minus 12t equals to 0, there we get t equals to 2 seconds. C. The value of t in seconds when the particle is at O again. So when the particle is at O again means that the s equals to 0, our displacement equals to 0. So get the function of displacement by integrating the function of velocity. There we will get s equals to 12t squared minus 2t cubed plus c. And again, when t equals to 0, the particle is at the fixed point O, which is s equals to 0, therefore c also equals to 0. So we can conclude that s equals to 12t squared minus 2t cubed. And when the particle is at O again, our displacement will be 0. So the 12t squared minus 2t cubed equals to 0, and we factorize it, become 2t squared times 6 minus t equals to 0. So we'll get t equals to 0 or t equals to 6. So he says again. Therefore, we don't want t equals to 0. The answer will be t equals to 6 seconds. Question number 3. A particle moves along a straight line and passes through a fixed point O with a velocity of negative 12 meter per second and an acceleration of negative 10 meter per second squared. After t seconds of passing through the fixed point O, the acceleration of the particle is a equals to m plus nt, where m and n are constants. The particle stops instantaneously when t equals to 6. Calculate. Assume the motion to the right is positive. A, the value of m and n. So, we asked to find the value of two variables. Check out the information that we can get. We have velocity equals to negative 12, acceleration equals to negative 10 meter per second squared when t equals to 0. So, from the function a equals to m plus nt, when t equals to 0, so basically a equals to m. And we know that when t equals to 0, the acceleration will be negative 10. So we know m equals to negative 10 meter per second squared. So now our function acceleration become a equals to nt minus 10. So the next information we have is about the velocity. So try to get the velocity function from the acceleration function by integrating nt minus 10. So we get n over 2t squared minus 10t minus 12. Oops. And the minus 12 because of when t equals to 0, our initial velocity will be negative 12. Therefore, supposed to be c will be equals to negative 12. So we can write v equals to n over 2t squared minus 10t minus 12. Now, when t equals to 6, okay, the particle stop instantaneously. The particle stop instantaneously when t equals to 6. So when t equals to 6, v equals to 0. So v equals to 0 by the t equals to 6. There we get our n equals to 4. B, the minimum velocity of the particle. When we want minimum velocity, then the dv dt must be equals to 0. So when we say dv dt equals to 0, that means the acceleration equals to 0. So we have function for acceleration with n is 4, m is negative 10. We get acceleration function actually equals to 4t minus 10. So when the 4t minus 10 equals to 0, then t equals to 2.5. So we want the minimum velocity. So get the velocity function and sub in the t equals to 2.5, we get minimum velocity equals to negative 24.5 meter per second. C, the total distance in meter traveled by the particle in the first 9 seconds. So let's sketch out the graph of velocity. There we see the particle stop when t equals to 6 and change direction. So for the first 6 seconds here, the particles move toward the left, and the 6 seconds is stopped, and this part onwards will be positive, means that the particle moves toward the right. So when we ask to find the total distance, we need to find the area bounded by the curve to the t-axis. So we do integration of the velocity. It's like we are doing the area from the integration. So if we find total distance, we will see the first 6 seconds, the integration will be a negative values because it's below the t-axis. So if we want distance, which is a scalar quantity that's only positive, we need to times a negative to it so that the negative will get a positive values. So we'll first times negative to the 0 to 6, integration of 0 to 6 of function v dt. plus 6 to 9, this part is above the t-axis, therefore the integration here will be positive. We just need to plus the positive terms. So after integrating, we'll get negative 2 over 3t cubed minus 5t squared minus 12t, okay, with the bounded of time 0 to 6, plus 2 over 3t cubed minus 5t squared minus 12t from 6 to 9. So sub in the 0, 6, 6, 9, we'll get all these values. So end up we get 189 meter. Question number 4. A particle moves along a straight line from a fixed point O. Its velocity v meter per second at t seconds after leaving O is given by v equals to 2t squared minus 5t minus 3. Calculate A. The displacement in meter when the particle stops instantaneously. When the particle stops instantaneously, the v equals to 0, and we need to find displacement, the s. So first of all, we'll get the function s by integrating the function of velocity with respect to time. So we get s equals to 2 over 3t cubed minus 5 over 2t squared minus 3t plus c. So when t equals to 0, s equals to 0, therefore our c equals to 0. So the function of displacement will be 2 over 3t cubed minus 5 over 2t squared minus 3t. Now, when the particle is stopped, the v equals to 0. Use back the function v equals to 0, and by factorization, we know v equals to 0 happen when t equals to 3. Now, with the t equals to 3, we can find the displacement when t equals to 3. So s equals to 2 over 3 cubed minus 5 over 2 3 squared minus 3 times 3. So we get s equals to 27 over 2. This is meter. B. The range of time in seconds when the particle decelerates. So when the particle decelerates, it happens 2 cases. So case number 1, when the particle moving to the right and the acceleration going to the left. So the particle experience decelerate. Or second case, when the particle is moving to the left but the acceleration pushing to the right. So it is also decelerate. So we check on case 1. When v greater than 0, we get 2t plus 1 and t minus 3 greater than 0, we'll end up getting t greater than 3. And when a less than 0, so 4t minus 5 less than 0, we have to integrate the v function. Where's the v function? Which is from 2t squared minus 5t minus 3. We have to differentiate to get the a first, so that we get 4t minus 5, and then less than 0, we get t less than 5 over 4. And we see there's no solution that happens when t greater than 3, and at the same time, it is less than 5 over 4. So therefore, we see no solution for case 1. Check about case 2. When the particle moves toward the left and the acceleration pushing to the right. So it is decelerating. It is slowing down. Alright. So when v less than 0, 2t plus 1 times t minus 3 less than 0, we know that t is from 0 to 3 because it cannot happen to be negative 1 over 2. So we'll start from 0. And the second condition is the a greater than 0, which is 4t minus 5 greater than 0, we get t greater than 5 over 4. So when we put these two linear inequalities into the number lines, we find that the intersection place is actually 5 over 4 to 3. Therefore, t is from 5 over 4 seconds to 3 seconds. The particle experience decelerate. C. The total distance traveled by the particle in the first 6 seconds. So total distance will first sketch out the function of v, okay, against t. So we get v equals to 2t squared minus 5t minus 3, and after factorize we get this. So if this function happens to be 0, we will have root negative 1 over 2 and positive 3. So with a minimum point graph, we get our function v this way. So again, we want to get the total distance from the velocity function. We can do integration of the velocity. And if we do integration, distance is always positive. But the integration of this part from 0 to 3 against t below t-axis will bring us negative values. So we will times negative values for the first part from 0 to 3 to the function of v dt. And then from 3 to 6, this part is above the t-axis, and the integration of this curve to the t-axis is positive. Therefore, we just need to plus from the integration of v function from 3 to 6. So we can see negative 2 over 3t cubed minus 5 over 3t squared minus 3t, 3 times 2 from 0 to 3, plus 2 over 3t cubed minus 5 over 2t squared minus 3t from 3 to 6. So by sub in all the values of 3, 0, 6 and 3, we will get these values and end up we get 63 meters. So the total distance traveled by the particle in the first 6 seconds is 63 meters. Number 5. High car place a remote control car along a straight track. The acceleration a meter per second square of the remote control car is given by a equals to 12 minus 40, where t is in seconds after the remote control car passes through a fixed point O. Calculate a, the maximum velocity of the remote control car. So when we ask to calculate the maximum velocity, we know that the dv dt must be equals to 0. When dv dt equals to 0 means that our a equals to 0. So we will get t equals to 3. So at the instant of t equals to 3, we have maximum velocity. Then we are given the function of acceleration, and we get the function of velocity by integrating 12 minus 40. We get v equals to 12t minus 2t squared plus c. And read through the question, we find no initial velocity. Therefore, when t equals to 0, v equals to 0, hence c here will be also equals to 0. So we get v equals to 12t minus 2t squared. So now we want maximum velocity. We know maximum velocity happens when t equals to 3. Therefore, when t equals to 3, we sub in to the function of v, we will get maximum velocity, which is 12 times 3 minus 2, 3 squared. So we get 18 meters per second. B, the values of t in second when the velocity of the remote control car is 0. So when the velocity of the car is 0, means that v equals to 0. So from our function v equals to 0, we get 2t times 6 minus t equals to 0, and t equals to 0 or t equals to 6. So the particle or the velocity of the remote control car is 0 happens when t equals to 0 seconds or t equals to 6 seconds. C, distance traveled of the remote control car in the 5th seconds. So we want the distance traveled by the remote control car in the 5th seconds. So we use S5 to minus S4. Alright, so function of S, displacement here. So we just substitute the substitute the t with 5, and minus the t with 4. We get 200 over 3 minus 160 over 3. So we get positive 40 over 3 meter. That is the distance traveled of the remote control car in the 5th seconds. Question number 6. The diagram on the right shows Aslan running across a straight bridge in 25 seconds with a velocity v meter per second. His velocity, v meter per second, t seconds after passing through point M, is given by v equals to 3 over 4t minus 3 over 100 t squared. Calculate. Assume motion to the right is positive. A. The value of t in seconds when the acceleration of Aslan is 0. So when the A equals to 0. So we are given the function of velocity. Get the function of acceleration by differentiating v. So we get A equals to 3 over 4 minus 3 over 50 t. So when A equals to 0, we will get t equals to 12.5 seconds. B. Maximum velocity of Aslan. Maximum velocity of Aslan happen when the dv dt equals to 0, which is when A equals to 0. And we know A equals to 0 happen on t equals to 12.5. Therefore, we substitute t equals to 12.5 into the function of velocity. So we will get maximum velocity equals to 3 over 4 times 12.5 minus 3 over 100 times 12.5 squared. And we get 4.6875 meter per second. C. The total distance in meter traveled by Aslan. So the total distance traveled by Aslan, we will first check, did Aslan change or stop and turn direction, okay, throughout the 25 seconds. So we'll try to equal the v to 0 so that we can get the value of t, okay, when v equals to 0. So we find that Aslan only stop when t equals to 0 and t equals to 25. So in between these 25 seconds, he will keep moving, alright, and in the same direction. So the total distance traveled by Aslan in the 25 seconds, we can just integral the function of v from 0 to 25 with respect to t. So we get 3 over 8t squared minus 1 over 100t cubed from 0 to 25. So after sub in the value of t equals to 25 and t equals to 0, we will get 78.125 meter. So the total distance traveled by Aslan is 78.125 meter. Thank you.